Now in this video we will see the continuation of the last part, where we will see how exactly we will design the branch type. Okay. So in previous cases there were immediate SRC. Okay, immediate SRC for load it was 0, because why we don't need to take a lot of bits and use it together, right? But here and also in S type the immediate SRC values were 1, because two bits were two immediate values were separately there in two places, which were reassembled to get 1. But here if you see, you have immediate like this the bits are split. 4 locations the bit are split. We know in immediate in the branch we have learned that immediate 12, immediate 10:5, then immediate 4:1, and immediate 11, like that 4 locations they are splitted. Since they are splitted into 4 locations, 13-bit split is happening here. So the value of immediate SRC here would be what? The value of immediate SRC here would be 10. Okay, this is very important thing, because in the previous cases was 0, that is 0 immediate SRC value for I type, and for S type it was 0, 1. Now for B type, for the branch type, the immediate SRC value is going to is taken as 10, because in 4 locations it is split. So it is split into 4 locations. 2 bits are therefore we need to select for doing this, for reassembling them together. So therefore the immediate SRC value is 10 here. So for load the immediate SRC value was 00, because it was a single bit contiguous 12 bit it is, because all of them are together. My immediate SRC for store it was 01, because two places these bits are split, so we have to reassemble them. Now immediate SRC for branch is 10, because in 4 locations the bits are split, so we have to again reassemble them. So now another question comes, why 13-bit is stored in 12-bit field? You have 12-bit field, but we take it as 13-bit. Okay, so there was this bit 0 that we have, 0 bit we have actually ignored, because it is always 0. Branch charges are always even address. It is never stored hardware. It is never stored. This bit 0 is not stored anywhere. It will be always 0 for branch charges. Branch charges are always even addresses. That is why it will be always 0. This last bit, that is bit of 0, would be always 0, because it is even address. Branch charges are even address, so you never store them. Hardware always appends a 0 as LSB. Automatically this 0 is appended. 0 is appended here. Hardware actually do that. So therefore it is something, because target is branch target is always even address, there would be a 0 always at the LSB, which is appended by the hardware itself. So therefore we don't need to separately store them. It is always already basically stored, so you don't need to separately store them. So you have understood about the immediate SRC. Now let us see here, there is an extra adder. Now why this extra adder is used? To calculate where you have to go, PC target, to calculate PC target. When you are branching, if you have to branch, then I told you the current instruction plus immediate offset we have to do. Now this is the -12's machine language in converted into hexadecimal form. So this PC value, this current instruction has to be added with this immediate value to get the PC target. So therefore this addition should happen here. In order to happen this addition, you need an adder, an addition adder, to run in parallel with our ALU. You need an addition adder, and you have ALU for subtraction. The ALU is used for subtraction, and there is an adder for doing this calculation. An extra adder is there for doing that calculation. Now ALU subtraction, we have already said in the previous video that if in ALU there would be source A and source B. If their value 0 means the ALU would give a 0 flag. So when it becomes 0, the 0 flag would be 1. So that means registers are equal. If the value is not 0, the 0 flag is 0. That means the registers are not equal. Understood? Otherwise the registers are equal. Now there would be a mux. Mux is used to select whether we have to use PC plus 4 or PC plus immediate. 1. Mux 1 means what? We are using PC plus immediate there. Understood? And mux 0 means what? Mux 0 means what? Mux 0 means it is PC plus 4 we will be doing. Understood? So PCSRC's value would be branch and 0. This we have already discussed. So when there is a branch, the 0, that is, this is a 0 flag value. 0 flag value can be 0 or 1. Branch is always 1. Okay, so branch is always 1. So 0 flag's value, but when branch is 0 means okay, there is no branch happening, then also it is PC plus 4. If branch value is 1 and if there is 0 flag is 0 means what? 0 flag 0 means what? You didn't get there 0. So that means you go to the next instruction. There is no jump. But when 0 flag is 1 means what? Okay, you get a 0 there. So PCSRC becomes 1. So branch and equal becomes jump. You have to jump. PCSRC is calculated using branch and 0. Let's say that branch is always 1. So then it depends on 0. 0 means the 0 flag which is coming from the ALU subtraction. So if the 0 flag's value is 0 means that okay, there is no 0 happening there. So that means our value of 0 is 0. Yes. And if the 0 flag's value is 1, that means there is a 0 there. So you have to jump. ഞാനൊരു റൗണ്ടാണ് അതിൻ്റെ ഉള്ളിൽ ഒരു അത് അച്ഛൻ്റെ കാറിലല്ലേ വെച്ചത് ആ മറ്റേ ഇങ്ങനത്തെ ഇല്ലേ റൗണ്ട് ഇങ്ങനത്തെ റൗണ്ട് ആ അതാ ചെറിയ റൗണ്ടുകൾ okay guys, sorry for that. So now you have understand this. Now let us see the next thing. Next thing is here. These are the control signals. Reg write is not there. Immediate SRC would be 1 0 because I told you 4 locations we have to control together. Now ALU SRC, does there would be an ALU SRC guys? You have to understand that thing. Is there an ALU SRC coming? Is there an ALU SRC coming? You have to understand that there is no ALU SRC because I told you there is no immediate value that you have to go to the ALU. Your ALU control would be 0 0 1 because we are subtracting. There is no memorite 0. Result SRC is something which we don't care. Now branch would be 1 because we have to enable the branch logic. So branch value is always 1. Now PC SRC is calculated using branch and 0. And it depends on the 0 value, if you got a 0 flag or if you doesn't get a 0 flag. These are the things, control signals which are there here. So this much if you understand, the other things are basically repeated again and again. Now we have to understand how this is basically executed. So first thing is that we will take the RS1 4 here and we will calculate the value in this 4 register 4, that is 14. Okay, that is 14. Then S4 is the, now in this A2 we will again calculate what is the value here in the 14. Fine. Then we will go to, pass it to the ALU. ALU SRC 0 because we don't need to calculate anything from this. We don't need to calculate anything from the immediate SRC. So therefore immediate value we don't need to get anything. We are just directly comparing 14 and 14 by subtracting. So now what will happen is that you find out while you subtract this value you get a 0 flag because 40 minus 14 is 0. So you get a 0 flag means what? 1. 0 flag, this 0 flag would be 1. Here you have ALU result separately. that ALU result is 0, which you have to not do anything. It's just ALU result is 0, but you have a 0 flag line here. That value would be 1. When you get this ALU result to be 0, the 0 flag would be 1. Now ALU control is 0, 0, 1 because you are subtracting here. This much we have understood. Now you have understood, okay, you get a 0 flag 1. This much we have understood. Now we don't care the result SRC or the data case because these are the parts of the previous things. Here no use of this is happening here. Fine. Now you got 0 flag 1. 0 flag 1 means what? 0 flag 1 means you have to jump. Easy. Easy. So that means you have to jump. So this here in the PC SRC is happening here. PC nest is there. Now you are jumping. You are jumping to the next instruction means this is the current instruction. You will take the first, you have to see where you have to jump. For that, I told you there is a separate adder that is required to calculate where you have to jump. The where you have to jump, this is a separate adder here. PC, that is the current instruction, you have to add it with the offset value that is here. The offset value is minus 12. So this 12 you have to take from the instruction, that is these bits here. You have to use the extender. So since the last bit is 1 means it is negative, so when you extend it you get 1 1 like this. So now we have immediate extend. This is minus 12 in machine language and it is now 32 bit. Now immediate SRC is 1 0 because from 4 different locations you have to reassemble those immediate bits. That is why the immediate SRC is 1 0. This much we have understood. Now that value minus 12 you have to add it with this current address. Then you get the new address PC target where you have to jump. Okay. Now this we have there. Now this multiplexer will decide whether you have to jump or go to the. Now this PC normal adder would calculate the next instruction, that is PC plus 4. Both are going to this multiplexer. This multiplexer would decide whether we have to go to this, that is this jump address that we have calculated here, or whether we have to do this normal instruction PC plus 4, which is calculated by this PC SRC. PC SRC is branch and 0. 0 value, 0 flag we got here, so it is 1. That means PC SRC's value is 1. If PC SRC's value is 1, the next instruction that would be executed is this jump instruction that you got, that is 0x1000, and not the next instruction that you got by PC plus 4. This is how this works. You check whether you get a 0 flag or not. You find the PC target and this multiplexer will decide whether you have to go to the next instruction using PC plus 4 or you have to go to this jump instruction. This is the only thing. This is so easy as this. You have understood that this branch is so easy. Just you have to understand the concept very clearly, then it's very easy. I hope you have understand this. If you have any doubts regarding this, please mention in the comment section. I will make a separate video if you have any doubts. The doubts video would be there. Thank you.